Good evening, guys. I am Raj Kiran here. On behalf of School of AI Trivandrum, I welcome you all to the day 10th of Python study group. Hope you guys have completed your mini project. I just want to remind you that 21st of this month, that is Sunday, will be the deadline for submitting the mini project. Also, there is a good news for you. Soon we will have a meetup. More details about the meetup will be mailed to you. In the meetup, the winners of the quiz competition will be rewarded. So these are the two things that you should keep in mind. One is the deadline, and the second is a meetup that is coming up. Moving to the content, let us have an overview of Week 5 Part 1. In Week 5, we learned how to handle errors. We learned about try and except, how multiple except work. We also looked at the keyword finally, and we ended the class with learning about custom errors. You can get this presentation by going to the following link: SoAI-Python-Week 5 of 2 tiny.cc/SoAI-Python-Week 5 2. As always, you can start asking your questions in the chat panel during the YouTube live. Or you can make use of WhatsApp or Discord channel. This is the content that we will be learning today. We will learn about decorators, how to create a decorators and use it. Then we will also learn about generators, how to create generator, how to use it. We will also look at the keywords like yield and next. So let's get started. I request everyone to open your Colab notebook and start coding with me. Decorators allows you to decorate a function. For an example, when you define a function, all you do is like start defining a function with the keyword define, def, start like def, then a function name, and inside that function you will do some simple stuff. Finally, you return something. So this is the normal way that you define a function. Now think of a scenario. What if you have to add some extra features or capability to an existing function? Let's imagine you need to do some extra coding in this part. Okay, so ideally what you will do is you will define a function and add the extra code there, right? And then return the function. So to tackle this problem, there are actually two ways that you can do. Either the first method is to add extra code to the old function. That is what we just did here, right? Add an extra code to the old function. But the problem here is that the original function will be lost. So you will no longer have the original or the previous function in hand. Now let us assume that you are going to create a new function. You are going to create a new function and copy paste whatever is left behind and add the extra stuff. So this will also be an issue. You will have to, like, the code will be redundant. If you have many lines of code, you will have to copy all those lines into the new function. This is not a good practice. So what is a better way to do this? This is when the technique called decorator comes into use. Decorator helps in adding extra functionality to already existing functions. We can make use of the operator to add a decorator to an existing function. It will look something like this. To an existing function, you can add a decorator using @ operator. Now let us dig deep into how we can create our own decorators. I'm going to define a function, hello, which just prints hi students, or let's say hello students. Okay. Now when we call hello, you can see the text being printed out, hello students. What if you do this? Now you get the object or the object of hello function. See, what you are seeing here is actually an object of hello. Like always, we can assign another name for the same function. I'm going to give it greeting, and I'm going to have assign it to hello. Okay. Let me go ahead and create some cells here so that Control M B, Control M B, Control M B. Now I have just assigned the function hello to a variable called greeting. Now I'll try to call greeting and it will return hello student. See, we just copied the function hello into a variable called greeting. What if we just try to print out greeting? It will say that function main dot hello. Now let us check if we actually created a copy or just made a reference to an existing function. What if we go ahead and delete hello? Okay, I have deleted hello, and now when I try to call hello, it will give me a name error saying that hello is not defined because we just deleted that function. In the previous step, we have already assigned hello to a variable called greeting. So will that greeting work now? See, it works. This shows that when you assign a function to another variable, it actually creates a new copy and assigns it to that variable. Now let us go ahead and look at nested functions. I'm creating some function. Okay. Inside that function, I'm going to print inside some function. Okay. Then I am going to define a function that is within this function called sum function. Okay, I will give a better name so that let's give hello itself. Okay, inside hello, I am going to just replace this with hello. Inside this hello, I'm going to define another function called greet. Sorry, Print \t inside read function, hello function. Okay, that's it. Now when we call the function hello, we will only see that this line is executed inside hello function. One thing that you have to make note of is that this is actually inside this function hello. You should see the indentation here. This is what we have learned in the class functions about scopes. This is called a nested function. So why is it that we are not seeing inside greet function? This is because we never actually called this function. We only defined it inside hello. Now let us call that function. Uh, Greet. Okay. Now I am calling that function inside this hello function. Now when we run this, now we can see that it will print inside hello function and it will also print greeting. Now we can have let me change this to return so that I can give you a better example. Print. Okay, let me check if that is working. Yes, that worked fine. Now I'm just going to make a copy of this and create another function called as welcome. Print it here. Copy that. It's here. Okay. So when we run this, now we can see that it is inside hello, inside greeting, inside welcome. We can also print this line here again. See? So this is how the nested function works. Now consider the situation. We are passing a value called as name equal to Manu. Okay. And I'm accepting that variable here inside main. I'm going to change it. I'm going to create copy of those cells. Okay, just created copy, and I'm now going to modify those. Going to give it a name called default. This is a default argument. Let's this be Ramu. Inside here equal to I'm going to pass Manu, and rather than just printing, what I'm going to do is if name equal to Ramu, I'm going to return that function itself. Let's say greet. Else I am going to return welcome. Okay. Now see, when we run this, it will go inside this function and print hello, right? Then it will return either greeting or welcome. Since we passed Manu, we will get the return as welcome. See, One thing to show you is that we can never call welcome from outside. See, even if we have defined that inside this class, we can never call that function outside. This is because of the scoping. This welcome is only available inside this function called hello, and it is not accessible outside. So rather than calling like this, let me assign like some variable, some function. Okay. Now when we run this, I actually get the output as print inside hello function. And the return function that comes from this hello function will be captured in the variable called sum function. So when we try to see that, now we can access that variable. When we try to call that, we can see that inside welcome function, which was this. So this shows that we can actually return functions from within a function. Now we have seen that we can do nested function as well as a function that returns a function. Another thing that we will like to explore is a function as argument. Let us say I'm defining a function good morning. And inside that function, I'm just going to print good morning. Okay. What if I need to add some extra line of code to this function? What I can do is create another function called, let's say, adding extra. And here I am going to some function. Okay, I'm going to pass some function. This name can be anything. I'm just using some function. So inside that, I'm going to print, hi guys. Hi guys. Sorry. Hi guys. And then I'm going to call some function. Going to call some function. And then I'm going to print thank you. Okay. Now we can see that I have actually added extra code to an existing function. So when we pass in good morning to this function, see, now we can get this as output. It will take this code and execute that within this function. This is what the decorator actually does for us. It will try to take in a function and then add some extra capabilities to that existing function. Now that we have looked at function as argument, function that returns a function, and function inside a function, we are all ready to learn about decorator. I'm going to create a decorator. I'm just going to create a function called our decorator. And inside that function, I'm going to do some extra stuff. What I will do is just copy paste what we have did here. Okay. And this also takes in some function. Okay. And we will return this extra stuff. Okay, so what have I done here? I have passed a function as argument and used a nested function to define a new function, which actually prints, hi guys, and then inside that function, I will try to execute the function that I have passed as argument, then I will print thank you. So this function is never being called. I will just return that function when I call this our decorator. So I'm going to use this and pass in our function that I have created, good morning. Okay, now when we do this, oh, sorry, I haven't executed this. We'll execute this line and then this. Okay, we will get a new function. I'm going to assign this as new function and then run. Okay, now we can see that I have got a new function which is actually a decorated function of good morning. We passed in good morning and created a new function with some extra stuff. So when we call this, we will get hi guys, good morning, thank you. So this is what a decorator does, or decorator capability is. We can reduce this step by just creating this function here and then just passing in at decorator. So what we just did here, what did we just do in this 3 line of code? We have defined our decorator rather than passing the function into our decorator and then assigning that to a new function. Python provides us with a concept called as decorator. We can make use of at operator for our operation. What it does is it will pass this function good morning into the decorator that we just created, and then it will return the new function and assign the name good morning itself. I will repeat once more. It will pass the function good morning to our decorator, and the new function that this decorator returned will be given the same name as good morning. So I will execute this line of code, and when we try to print, when we try to call good morning, now we can see that it actually takes in hi guys, good morning and thank you. It actually takes in this line and add those extra steps. This line of code can be anything that you need in your work. You can replace these lines with anything that you can, like you have a function and you want to add some more capabilities. This is the proper way that you can do it. The main advantage is that you can actually turn on and off. You can remove this decorator and this function is back to normal. And if we add this decorator, we have just decorated an existing function. So this is the entire concept about decorator. We have learned what is a decorator, how to create a decorator, and how to use it. Now let's move into the next session, that is generators. Generators are functions that allows us to write a function that can send back in a value and later resume where it is left off. Sends back where it is left off. It allows us to generate a sequence of value over time. The main difference between a normal function and a generator function is that there will be a keyword called yield. Generator function actually don't return a value and exit. It will automatically suspend and resume its execution and stay around the last point of value generation. The advantage of generator is that instead of having to compute an entire series of value and storing it in memory, it will compute one at a time and wait for the next call. Okay, let us look at an example. I am going to create a function called create squares, and I am going to pass in a number, let it be n. I'm going to have a result which is a list for x in range of n. What I'm going to do is append square, that is x square, to this list. Finally, I'm going to return the result. Okay. Oh, I absolutely forgot to zoom in the screen. I'm extremely sorry, guys. Okay. You will have little difficulty, I guess. You'll just scroll through this line so that you can pause and read if something was unclear to you that time. Okay, I'm just scrolling to this thing. I'm extremely sorry, guys. I just forgot to zoom in. Okay, now this is what we have learned so far, and then we moved on to generators. Okay, now I am going to call this and pass in a value of 5. Okay, now we can see that it actually returns. Let me start this from 1. Okay, it actually returns squares from like 1 till 5. Square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16. We don't actually get the square of 5 because we have only added n. If you want 5, you can add in plus 1. That will give you till that number. Okay. So imagine this scenario. What if you pass in a large number here, like 10,000 or something? Okay, I'm not going to run that. What it does is, it will go and try to call this function. Okay, for each iteration in this function, it will calculate all the possible computation that it needs, and it will store that value inside the list called result. So in our program, maybe we only wanted one element at a time, like for each element. Okay, in I'm going to print each element. Okay, so in our code, like we actually want each element at a time. We actually don't want the entire list to be pre-computed and kept in memory. So if we have passed like 10,000 over here, what it actually does is it will try to compute the entire sequence, that is the value up to 10,000, and it will try to store the entire value in the memory. This is not efficient. That is where the concept of generators comes into play. It will only compute one value, and rather than exiting from that function, it will stay alive. And when you try to compute the next value, that function will be invoked again, and only at that time the next value is computed. That is the fun advantage of generators. Now let us convert this function. I'm just going to copy this line and this. copy those and paste it. Okay. Now what I'm going to do is I'm going to remove this line, remove this line. Rather than appending, I'm just going to use the keyword called as yield. This is it, guys. We have just converted our function into a generator function. So when you try to call in, phi, now we can see that we actually doesn't get the entire output. This is because generator function will never compute the entire sequence in a go. What we are seeing is actually a generator object. We can now make use of that generator object to get the same output. See, we have run this cell, which is a generator object. Okay, what it does is it will compute the first value and return as each element. Then this function stays awake in the memory rather than exiting. Then during the next iteration, it will go and then compute the next value and return that value to each element. This is how the generator works. So you can actually get the entire list by converting this to a list object. See, now you can get that entire list. This is all about generators. Now we will also look at a thing called as next, a keyword called as next. I'm going to define my generator. This is just generator, and inside this I am just going to x in range of 3. I'm going to yield yield x. Okay, I just created my function, which is a generator. Yep, it is a generator. And rather than calling this function like this, I am going to use the keyword called as next. Okay, you can see that when I call next, it actually gives me the first element which will be returned by this generator function. When I use that next keyword again, I will sorry guys, I actually need to make this uniterable. Let's have seen like give it an ing. G. Next of G. Okay. Next of G. Okay. We are actually iterating through every values in that function. So we actually only put in range as 3. So what if I call this B? Now I will get an error message called stop iteration. So when we call a function like for x in my generator, right? For x in my generator, what I'm going to do is index. Okay. So what this for loop internally does is it will call this next keyword, and when the last element is complete, this for loop will catch the stop iteration and will handle and execute this line of statements. It will exit from this line of statement once this exception is caught. So all that is being handled internally. So this is the use of generator. So we know that what we just did here was converting that to an iterable. So I can create a string called as hello, right? What if I call next on yes? See, we will get an error that we know that this string is actually an iterable, right? So string is not an iterator. This is the error that we will get. So what we can do is that we can actually like iterable string which is equal to I am going to use a keyword called as iter and pass in yes. So now this string is being converted to an iterable string. See h. I will get h, and then when I pass the next thing, I will get e. See, we have just converted this string hello into an iterable. Okay. By iterable, what I meant is that we can actually like control on b for I in yes print I. It actually prints this, but even though it prints each element wise, we are not able to use next on this yes. See, so that can be at like doable with a keyword called as iter. So this is it, guys. This is what you need to know about generator. That is, we will make use of a keyword called yield, which is more efficient. This makes this concept of generator was one of the main difference when from comparing from Python 2 and Python 3. This generator had made Python 3 more efficient. So that's it about generators and decorators. Thank you, guys. You have done a great job by attending this class. Now it's time for you to ask some questions if you have any. You can also make use of WhatsApp or the Discord channel if you have any doubt. Thank you, guys.